Okay, so today again we're going to review common factors. So this shouldn't be anything new. You would have learned about this last year. So what is a factor? We're going to start right from the beginning. Did I give you guys this note? In my mind I did. You're welcome. You're welcome. You're welcome.
Thank you.
You're welcome. Okay, so a factor. A factor is something that divides in evenly, so you'll get an integer if you divide into any number. So if we talk about factors of 12, what are my factors of 12? Give me one factor. Nathan? 2. 2 is a factor of 12. What else is another factor of 12, Laura?
4.
Yep. 4 is a factor of 12. What else, Jericho? Good. What else is a factor of 12? Austin? Yep. Ooh. What else is a factor of 12? Zach? 6 is a factor of 12. I have one more factor. What is it? Caitlin? 1. Okay, those are all my factors of 12. And our goal today is we're going to find the largest factor of multiple numbers that they have in common. So the greatest common factor is the largest number that divides evenly into all of the numbers in a question. So I have 3 numbers here for you. 16, 14, and 28. What is the greatest common factor for 16, 14, and 28? My greatest common factor. What do you think that would be? What number divides, what's the biggest number that divides into 16, 14, and 28? What is it? Nathan? That may be a multiple. It's not a factor because I can't do 28 divided by 48. What's my greatest common factor here, Nick? 4? Okay, 4 is a factor of 16, right? Because 16 can divide by 4. Is 4 a factor of 14? 4 is a common factor for 2 of them. What's the greatest common factor for all 3? Vanessa? 2. Okay, that's pretty, it's pretty basic. So what you would want to do is, again, you would divide each of them by 2. Does that work? Yes, it does. Is that the greatest common factor? Can it be divisible by any more? No. What about -2, -8, or -10? What is my greatest common factor here? What's the greatest common factor? Austin? -2. Yeah. Typically, if you have all negatives, you want to factor out a negative. So if I gave you a -2, -8, -10, you're going to factor out the greatest negative number. Get rid of all those negatives. Okay, so you're right. I can divide 2 by 2, I can divide 8 by 2, and I can divide -10 by -2. Okay, so those would all be my greatest common factors. Anyone have any questions about that? Okay, I want you to do that one for me. What is the greatest common factor on your desks? Write it out of 4, 12, and 24. What's my greatest common factor? You can use your multiplication chart to help you out. What's the greatest common factor? If you had to come up with a strategy how to determine what the greatest common factor is, what would your process be? Do you know? Nathan? Yeah, if any of those numbers go into each other, what's the maximum greatest common factor? Why? Yeah, you're always going to look at your smallest number. My smallest number is 4. So I know it will either be 4 or it will be a factor of 4. Okay? So those are that's kind of a strategy. So what is my greatest common factor here? What is it? 4. I can do 4 divided by 4, that gives me 1. I can do 12 divided by 4, which gives me 3. I can do 24 divided by 4, which gives me 6. Okay? We're going to go back to the note. There's another way we can factor, and it involves variables because we've been dealing with variables. So this one's a little bit different. It says variables can also be part of a common factor if the variable is found in every term. So the rule is the greatest common factor of variables is the term with the lowest exponent. So if I look here, what is my greatest common factor between 7x and 10x? What's my greatest common factor? That's okay. First of all, I looked. Does every term have a variable that's the same? Yes, it's both x. What's the lowest exponent? Here's an exponent 1. Here's an exponent 1. My greatest common factor is x. What about in the next one? M to the exponent 4, m cubed, m squared. What is my greatest common factor here? Jericho? Just m? Yeah, m squared would be the lowest exponent. When you're talking about variables, yes, it's the lowest exponent. But they all have to have the same variable. So those are all m's. Okay, try this one out. We're going to do it. We're going to do examples of that. We're going to put them together. So I have 3 terms here. This one's a little bit different. I have x cubed y, x to the exponent 4, y to the exponent 8, x cubed y to the exponent 4. What is the greatest common factor between those terms? Those 3 ones. Remember, we're choosing the lowest exponent. Nope, you're doing it on the desk. Break each part up. Look at your x's, look at your y's. What is the lowest x? What is the lowest y? I know, I saw that. Okay, what did we come up with? If I look at my x's, what is my lowest x? What's my lowest x? Anyone? X cubed would be my lowest x, because I have a cubed, a 4, a cubed, okay? What is my lowest y? Austin? Just y. So my greatest common factor is x cubed, y. Okay, now I double photocopied one page for you, so I apologize. Just kind of skip it, and then we're going to go to the next one. Now we're putting both pieces together. So we've looked at just numbers and just variables. Now we're going to combine them. So when you're factoring, you want to find the greatest common factor of the coefficients, which is the number in front of the variable. And then the next step is you want to find the greatest common factor of the variables. So it's like a two-part thing here. I'm going to look just at the coefficients. So my coefficients here are 10, 5, and 25. What is my greatest common factor between 10, 5, and 25? Jericho? 5. So I'm going to write 5 down. I know it can't be any bigger than my lowest one. So 5, and then 5 divides into 10, 5 divides into 25. Okay, now I look at my variables. I have a xy here, an ax here, an xt here. What will be my greatest common factor for the variables? Nathan? No, because a isn't in here and t isn't in here. Y isn't in here and t isn't in here. It's just x, because x is common to everything. I have an x here, an x here, an x here. Okay. What about 36x to the exponent 4 y cubed, 12x cubed y to the exponent 5, 18 y to the exponent 7x? The first thing I want to look at is my coefficients. What is my greatest common factor for those three numbers? 36, 12, and 18. Caitlin? 6. Very good. Now what would it be for the variable? What would it be for the variable, Austin? X, y cubed. Huh. Let's look. X, y cubed. I have x to the 4, 3, 1. So it is 1. I only have one x. I have 3, 5, 7. Y cubed. How are you with this? Do you feel comfortable with this? Okay. So when we factor, we know how to find the greatest common factor. Factoring is the opposite of what we have done these last couple days. These last couple days we've been expanding, which is another way of saying we've used the distributive property. So this is expanding. When we expand, we would use the distributive property, and negative 5 times a gives me negative 5a. Negative 5 times positive b gives me negative 5b. Factoring is the opposite. Factoring is saying, okay, what does this term and this term have in common? Well, they have a 5 in common. Typically, if you can factor out a negative like this, we do factor out a negative. So I would factor out negative 5 is common to that. So I would put, that is my greatest common factor is negative 5. And what I do is I would divide each term by my greatest common factor. So I would divide this by negative 5, divide this by negative 5. So what would I be left with? Well, negative 5 and negative 5 cancel out. So I'm left with just a. Positive 5 divided by negative 5 leaves me with? It leaves me with a negative b. When I'm factoring, I'm dividing. So I'm left with negative 5 . Oh, thank you. It is a dash. Thank you, Nathan. So divide by 5, divide by 5. There, that makes things better. Sorry, guys. So again, if you look, these should be the same thing. When I expand, that should be the answer I get when I factor. So you can always check your work to see if this works out. So again, you have to remember that we're dividing. So it says here is steps that you can refer to. To factor, you must take the greatest common factor followed by a bracket and divide each term by the greatest common factor. So if I ever say factor, you should have brackets, okay? And you're going to divide each term by the greatest common factor. You can check your answer by using the distributive property. So, looking here, I have two terms. What is my greatest common factor? What's my greatest common factor between 6 and 15? Zach? 3. Do I have any variables that are common? No, this one has an A, this one has a B. So what I would do, I should have left more room. What I should do, my greatest common factor is 3. I'm not going to be showing this step outside of this example. So I'm just going to show you this middle step. If you have to do this every time, then you do it every time. But you should be able to get it until you've had practice with this last year. So if my greatest common factor is 3, I'm going to divide by 3 for each one. So when I come up with my final answer, I take my greatest common factor, which is 3, followed by a bracket. So I'm going to write a bracket in here. And then now I get, what would I write on the inside of this bracket once I divide each term by 3? Nathan? 2a minus 5b. Does anyone have any questions about this? Does everyone remember this from last year? I hope so. Okay, what about this one? I'm going to write my greatest common factor for 4a squared b cubed minus 5a cubed b cubed. What is my greatest common factor here? Nick? Yeah, or I'm just going to say a squared. The one's implied, but you're absolutely right, Nick. So I take that common factor, and what I'm going to do is divide by a squared. Divide by a squared. So when I write my answer, I'll take my greatest common factor, which is a squared, and I know I'm going to have a bracket. Okay, what do I write now? How do I factor out these variables? What do I write, Austin? Okay, these two cancel out. Okay, can you explain how did you get this? Take a minute, look at this, and explain how did you get this? Why does that make sense? Nick? Good. When I divide, I subtract the exponents. So I have a 2 here, a 2 here. 2 minus 2 gives me 0, which is why I don't have an A in this first term. I have an A3 here, an A2 here. 3 minus 2 leaves me with 1A, which is why I have 1A there. Okay? What about this one? What would be my greatest common factor for this one? What would be my greatest common factor for this? Zach? 7A squared. So that's like me saying I divide each one, 7A squared, divide by 7A squared, divide by 7A squared. So when I write my final answer, I know I'll put 7A squared on the outside. It's followed by a bracket. What am I left with inside that bracket after I factor this out? What am I left with? Nick? 4A squared. Good, because 28 divided by 7 gives me 4. 4 minus 2 gives me 2. Minus, what did you say? Minus 2A. Why do you say plus 1, Nathan? See how I have 3 terms here? I should have 3 terms inside my bracket. When you are dividing something by itself, 5 divided by 5, 10 divided by 10, you are always left with 1. So I do have a plus 1 here. Are we okay with this? Okay. I want you to try these 3 examples on your desk. Go. Okay, let's try this one out, the first one. What is my greatest common factor for my first one? Zach? 25 k squared m squared. So that's my greatest common factor. Now, what am I left with when I take this greatest common factor and I divide it by each of the terms? Zach? 4m minus k. Okay, so I'm not showing that middle step. If you don't have to show that middle step, if you can do it outside in your head, that's fine. Laura? I have to look at my lowest exponent for k. I have a 2 and a 3. What's my lowest? 2, so that's why I have a squared here. So I'll have 2 minus 2 for my first one, which gives me 0k. Then I'll have 3 minus 2, which gives me just 1k. Do you want me to write the middle step for you? I'll do it. Okay, I'm just going to write the middle step in here. So I divide each step 25k squared m divided by 25k squared, it's m squared. Okay, so my k squareds cancel out because there's a 2 and a 2. 100 divided by 25 gives me 4. I have an m cubed and m squared, so I do 3 minus 2, which gives me 1m. 25 divided by 25 gives me negative 1, which is right here. I have a k cubed, a k squared, so 3 minus 2 gives me 1k. And my m squareds cancel out because it's 2 minus 2. Okay. The next one, what's my greatest common factor for this third one? What's my greatest common factor, Nick? 5xy. So I know I write 5xy on the outside of a bracket. And when I divide 5xy by everything inside that bracket, what do I get? What do I get? Austin? X minus 2y plus 4. How many of you got that answer? So because there's an x and an x, so they cancel out. Because 1 minus 1 gives you 0, so you should have 0 x's. Okay, what about my third one? What's my greatest common factor for my third one? This is a big one. Nathan? 9a squared. What was it? Good. Why isn't b? Why can't I put b in there? Austin? Good. This doesn't have a b in it. You would lose half a mark because that's not the greatest common factor. Okay, what am I left with when I take 9a squared c squared and I divide it by everything on the inside of that bracket? What do I get? Jericho, you want to help me out? 2 what? Good. Very good. So if I look here, 3 minus 2 gives me 1a. I have to include my b squared. 4 minus 2 gives me 2c, or c squared. I have minus. What will I write in next? Kaylee, can you help me out? What did you get? 4a squared c. That's perfect. Ben, can you help me out next? I'm going to factor out 9a squared c squared from my last term here. That's okay. So I start with my coefficient. 27 divided by 9 gives me?
That gives you 3. So.
Good.
Okay, and then a squared.
I have a squared. I'm factoring out an a squared.
Yeah, so it's
B squared, good.
Yeah, that's it.
Yep. So again, a squared, I'm factoring out an a squared, so 2 minus 2 gives me 0. B squared, I'm not factoring out a b, so I write that. C squared, cancels out, so I'm left with that. How many of you would have gotten perfect on that? Okay, all right, erase your desks. Yes?
So for the numbers, you just subtract them?
For the exponents, you subtract them.
Did you tell us this before?
Yes.
When?
10 minutes ago, 15 minutes ago? What do you mean?
Like,
Before today?
yeah.
No. You would have learned that in grade 10. Yes, in apply you do learn that. Yep. Okay. All right. We're going to do one last thing here. Binomial common factoring. To factor a polynomial with a common binomial, think of the binomial as one factor. Okay, binomial means two terms. If I look here, you're welcome. What does this have in common? What do I want? I want my highlighter. I have 4x bracket x minus 7 plus 3 bracket x minus 7. This is common and this is common. So all I do is I factor it out. That is the greatest common factor. Now it's really easy when you do this because you would divide by x minus 7. I would divide by x minus 7. So that means x minus 7 is my greatest common factor. So that goes on the outside. When I divide each term by x minus 7, what would I have left over? What would I have left over? Austin? Plus 3. So it's really easy when you're factoring out a common binomial. They just cancel out. So I'm factoring it out so it goes on the outside, x minus 7. And then on the inside, I'm left with 4x plus 3. Because you're taking the whole thing out. If you don't put the x minus 7 in brackets, okay, if you don't put the x minus 7 in brackets, then that's saying this, x minus 7 times 4x plus 3. That's very different because that's saying just the negative 7 you would multiply in. If that's not the case, you have to multiply this whole thing into the bracket. So you have that. Anything you factor out, you're always putting on the outside, and when you're factoring out a binomial, it will always be in brackets. So what's my greatest common factor in here? Is a plus 2. So I know I'm going to put that on the outside, a plus 2. When I divide each of these by a plus 2, what will I be left with on the inside of that bracket? 6x minus 1, because there's a 1 out here. So it's literally like I'm removing this, what's in the brackets, and writing what's left over. The key thing is that they have to be exactly the same. A plus 2, a plus 2. Okay, are these binomials the exact same? No, why not? What, Laura?
Is X just the greatest common?
No, x isn't the greatest common factor. I would have a lot of students who would factor out this x minus 2, but why can't I do that just yet? Kevin? The 2 is negative here, and the x is negative here. So they're so close that I could almost factor it out, but I can't. When this happens, when the signs are different, anyone know what you can do? Pardon? I'm not going to do the distributive property. Nathan? Yeah. What we're going to do here is we're going to factor out a negative. If I factor out a negative, then it will be the same. So when I'm factoring out a negative, I'll rewrite this as 3x bracket x minus 2. When I factor out a negative, that means instead of writing plus 4 here, I'll write minus 4. When I say a negative, I should write, so I'm going to put here negative 1, which is why this positive 4 becomes negative 4. And then everything inside this bracket, when I factor out a negative, becomes its opposite. What's the opposite of 2? Negative 2. What's the opposite of negative x? Positive x. So now, even though they're written in a different order, I still have 2 as negative. I still have x as positive. This is a common binomial. Okay? Anyone have any questions with what I've just done? So when I factor out a negative 1, this negative occurs here, and the signs change, which makes a common binomial. So what will I write for a final answer here? Nick? 3, 3x minus 4. Good. Okay, I would like you to try these two examples on your desk. Good job. Good job. Careful, are these the exact same? Are these the exact same? Hmm? Yes. So when you factor out a -1, what does that become? Yeah. Good. Yep, that's perfect.
Really?
Yeah. And then, well, now you got to do the next step. Good. Good. Excellent. Good. Are these the exact same?
Yeah, they're slightly different.
Yeah, so when it's a bit different, that means I have to factor out a
The exact.
-1.
Yeah.
So what does that change this to?
This to a positive.
Good. So I'll rewrite this as 4a x minus 3. So you said this becomes a positive.
Yep.
And then what changes on the inside of the bracket?
Inside the bracket, the 3 becomes negative,
Good.
and then the x becomes positive.
Good. Now you can do it. Okay? Okay. This is an example of so close, but not quite there. How do I have to rewrite this so I can factor out a binomial? What do I have to do here? I saw a lot of you do it. We have to factor out a -1. So it would be 4a bracket x minus 3 plus 2. So I change that sign because I'm factoring out a -1. And then this becomes -3 plus x. So now these two binomials are the same. I had to factor out a -1 because these were not the same, which is why this -2 becomes a +2. When I factor out my binomial, I'm left with this. How many of you got that? Okay, good. The next one, if I look here, okay, are these the same? Are these binomials the same? Yeah, they are. They're just flipped. The 2's negative, the 2's negative, the b's positive, the b's positive. So you would just rewrite this as, oops, not 6, b minus 2 times 3a plus 6. We okay with that? All right, you can erase your desks.